As we complete section 1.3, we're in part C. We're going to do examples of what we just studied or ended in looking at our designs between observational and experimental types. So we want to identify the type of observational study, which were three of them: cross-section, retrospective, or prospective. A research company uses a device to record the viewing habits of 5,000 households and the data collected over the past 9 years. Okay, past is a clue, right? Past 9 years. To determine whether the proportion of households tuned to a particular new program increased, if the new program increased the viewership. Of course, the key here is past, so that's retrospective. Now we're going to identify which of these designs is most appropriate for the given experiment. Completely randomized design, randomized block design, or matched pair design. And here we're talking on experiments. Lunesta is designed to treat insomnia. In a clinical trial of Lunesta, amounts of sleep each night are measured before and after subjects have treated with the drug. And that is matched pair. Before and after treated. So that was defined in that lecture right before. Identify which of the designs is most appropriate for the given experiment. Randomized block or matched pair. Sorry, I have a little catch in my throat. So in this one, it says currently there is no approved vaccine for the prevention of infection by West Nile virus. A clinical trial of a possible vaccine is being planned to include subjects treated with the vaccine while other subjects are given a placebo. And this is a completely randomized design. Right. So as we continue on in learning about the structures and the possibilities of doing statistics, we always have to consider what errors could happen. Now, this isn't an entire list, but it is one that gives you an understanding of being careful in your structure, your organization, your design of your study. Okay. No matter how well you plan and execute the sample collection process, there is likely to be some error in the results. The first one is sampling error or random sampling error. Occurs when the sample has been selected with a random method, but there is discrepancy between the sample result and the true population result. Such an error results in a chance of sample fluctuations. The word discrepancy, sorry about that, um, implies the lack of planning. to get a section pool representing population. This one is easy to do because we throw in convenience or familiarity with whatever area you live in. And that does not represent the true population and what you could get as a result of the sampling error from random sampling. Next one that we have is called non-sampling error. Non-sampling is a result of human error, including such factors as wrong data entries, computer error, questions with bias wording, false data. This one is really serious. And as we get into our data entry on our calculator, garbage in, garbage out. Oops, can't spell. And we talk about that as part of how you gather and input data, and it's the human error can cause a multitude of problems. On a sampling error, you have to always double check, and it is boring. Statistics can be boring if you leave it in the hands of other people to input. It's just serious. And then we have this one, non-random sampling error. Non-random sampling error is a result of using a sampling method that is not random, such as convenience or voluntary. These two are the booger bears, not sound procedure. All right. So we have, this is our last example, and it says a medical research, the researcher tested for a difference in systolic blood pressure levels between male and female students who are 12 years of age. She randomly selected 4 males and 4 females for her study. Well, the type of study is observation. They aren't receiving a treatment. She's just looking at what happens with this blood pressure, systolic blood pressure. Because the researcher did not attempt to modify the individuals. What is the major problem with the study? Well, sample is too small. And not sure if it reflects the population. All right, there you have it. We've introduced a lot of material on this one, but if you keep it simple, it'll make sense. If you just focus a little bit on what the big picture says, you'll have no issues, and you can recognize the many studies of sampling and resources used. to validate a study. One of the most important mathematics that we have in our uh, community, and it helps us fend off problems. It helps us plan where to put a stoplight versus a stop sign, where the traffic flow build roadways that allow us to go quickly to the area that we want to be in as Waco expands. Also, too, it is delivery, the delivery and accessibility. Where do you put the hospitals that best service the population of Waco? And do we need another one? So, what did Waco do? Well, you've got all these clinics that you can go to for 24-hour care of simple things instead of loading the hospitals with general flus and colds and those type of concerns. So be thinking about how these work and what the purpose is. Thank you for listening.